Uh, for the previous discussion, okay, on this Taylor design chart, okay. So we need to look on the phi value, okay. For example, when we want to use the ND, okay, which is this one, okay. So it refers to the phi value when the phi is equal to 0, okay. So we have 5, 0, okay. And then we also have the phi value of 5, 10, 15, 20, and 25. Okay, for the first example, okay, so when the phi is equal to 0, okay, so then we may need to get what is the value of the ND. Okay, so for the other example, for the other phi value, which is more than 0, it doesn't require for us to determine the ND value. Okay. So actually the ND value is related to the type of the failure. Okay. Either it is toe, midpoint, or slope. Okay. Because normally if it is a purely cohesive material, so it have potential to fail in this type of failure. Okay. So that's why for the first example, so um, we need to determine the ND. While for the rest example, okay, for example, number 2, for example, uh, 5.7, we need to determine the ND. Okay. For 5.8, it doesn't require for us to determine the ND, okay, because the phi is equal to 10. Okay. So the other one is when the phi is equal to 10. Okay. Okay, and the last one is also when the phi is equal to 5. Okay. Okay. So that's the reason why for the first example 5.7 we need to determine the ND. Okay. So now we move for the method of slices. Okay. Okay. So this is method of slices. In this method, the potential failure surface is assumed to be a circular arch with center O and radius R. Okay. So we look on this figure. Okay. So the solid mass ABCD above the failure surface AC is divided by vertical plane into a series of slices of with B. Okay, the base of each slice is assumed to be a straight line. For any slice, the inclination of the base of the horizontal line to alpha and the height of the center of the measure at the center is h. Okay, so okay, this is an example of what we call as of the method of slices. Okay. Okay. So here this is equivalent. This is R. Okay. Then we have several slices. Okay. So for example, if it have a two layer of soil, okay, example here, we change the color first. Okay. So if it has a two layer of soil, okay, when we want to construct for the slice, okay, so we need to make sure that the slice, the bottom part of the slice or the failure surface should only cover one type of soil. Okay. So for example, for this case, okay, so for the slice, sorry, soil number 1 and soil number 2, so uh, it represent at the base of slice number 8 and number 9. Okay. While for 1 to 7, okay, it only represent one type of soil. at the base of the surface failure. Okay, so make sure that when we want to draw the slice, okay, make sure that the base only cover one type of soil. Okay, do not, for example, okay, do not, okay, let's say, okay, this is the second the difference between second and first soil. Okay, so this part, okay, has been covered by soil number 1. Okay, while this part has been covered by soil number 2. Okay, so it's very difficult, okay, when we want to do the analysis later on. Okay, so in that case, it's better for us to extend the width of the slice number 9 and then reduce the width of the slice number 8. Okay. So what is the minimum number of slice? So it depends. Okay. For example, if we want to have a more accurate result, so we should have more slice number. Okay. So we just imagine the force acting on this each slice. Okay. So we have a normal stress, okay, acting at the bottom. Okay. And also it has a side side stress, okay, on the normal side stress on the slice. Okay. And it also has a vertical side stress on the slice, which is X. Okay, this is the E. Okay, this is the weight of the slice. Okay, and it also have the T. Okay, to represent as the resistant force. Okay, so actually, for a basic derivation, okay, we not include the pore water pressure, okay, in the formula. Okay, so later on, Fillenius, okay, Fillenius has add what we call as the pore water pressure. Okay, however, he has assumed the E and X is equal to 0. Okay, so it doesn't include the E and X in the analysis. Okay, sorry, the first one also doesn't include, assume the X and E is equal to 0, and then Fillenius add the pore water pressure in the analysis. Okay, and the last, the Bishop. Okay, okay, we only cover for 3 type of method of slices analysis. Okay, the first one is the original one. Okay, and then improvised by Fillenius, but include the pore water pressure. And then Bishop. Okay, so he has include the X and E. Okay, the summation of X and the summation of E has a certain degree. Okay, and also include the pore water pressure. Okay, so in that case, Bishop provide more comprehensive analysis compared to the Fillenius. However, it's very tedious. Okay, we may look on the example later. Okay, so that is the assumption made by Fillenius, or assumption made by the ordinary method, and then improvised by Fillenius, and then improvised by Bishop. Okay. As before, the factor safety is defined as the ratio of the available shear strength to the shear stress acting on the plane. Okay. We have the tau F over tau M. The factor safety is taken to be the same for each slice, implying that there must be support between slice. Force must act between slice. Okay, so that is the how they identify the X and E. Okay. Sorry, this E and X. Okay. Okay, so on the slice, okay, the total weight of the slice W is equal to gamma BH, so that is the W, okay. So the total normal force on the base, okay, the effective normal force, okay, so this is the derivation on how they come up with the equation later on, okay. So then we have then normal stress is equal to uh, sigma time L, and then the boundary water force, which is the nu, okay, U nu time L, where U is the pore water pressure at the center of the base and L is the length of the base. Okay, so the shear force on the base is T is equal to tau M time L. Okay, the total number of the force on the east side, on the side, which is E1 and E2, then they have a vertical or a shear force on the side X1 and X2. So any external force must be included in the analysis. Okay. So for example, if there is a road on the berm or on the top of the soil, on the top of the slope, so we need to include in the analysis as well. Okay, but make sure that the unit is same. Okay. Okay. So assumption must be made regarding the interslice force E and X. Okay, so this is a simple one, okay, where they assume E and X is equal to 0 and there is no pore water pressure taking place. Okay, so then taking moment O and the sum of the moment of the shear force T on the failure arch must be equal to the moment of the waste of the soil mass. Okay, so this is the derivation. Okay, and later on they come up with this kind of equation based on the effective stress. Okay. A similar concept with the total stress, okay, where we use the moment, okay, where the resisting moment divide with the driving moment. Okay, so this is for the ordinary slope method, ordinary method of slices analysis. Okay, then a little bit in improvement, okay, has been made by Fillenius. Okay. Fillenius assumed that the result of the interslice force is 0, but the pore water pressure exists at the base of the slice. Okay. So then include the pore water pressure value. Okay. So from the previous one, it doesn't include any pore water pressure. Okay. And by including the pore water pressure, the equation has been improvised. Okay.
Sorry, Doctor.
So the component W cos alpha can be calculated or measured. I'll discuss on how to Ya, kenapa? Tak ada? Hello?
Aku sangkut sikit suara Doktor.
Sangkut Alamak, sorry.
Sangkut.
Ya.
Dia macam sekejap je jelas, lepas tu terus putus-putus.
Dengar tak? Dengar tak?
Dia macam dalam
Dalam gua?
dia macam tu sikit tadi. Sekarang cuba cak tu tadi.
Sekarang okey?
Sekarang okey dah.
Okey lah, sorry.
Dia putus-putus.
Okay. I repeat again. Then Fillenius improvised the ordinary method of slices, okay, by introducing the pore water pressure. Okay. So then the N prime is equal to W cos alpha minus pore water pressure times L. Okay. So that is the improvement made by Fillenius, okay, by including the pore water pressure. Okay. And when we compare with the total stress method, so it doesn't include the pore water pressure. Okay, so that's why there is a lot of difference between this effective stress approach with the total stress approach. Okay. Okay, the next is improvement made by Bishop. Okay, so by uh, Bishop assume that the effect of force. Okay, please download the new notes because I just revised the notes. Okay, and then I just include this section. Okay, so please download the new notes. Okay. So Bishop assume that the effect of the force on the side of each slice are accounted for to some degree. Okay. So then, okay, they introduce he mentioned that there is a force, okay, that should be count, okay, for the P and also for the T, okay, or in our previous discussion, it is X and E, okay, the same term, X and E, okay, but in this diagram, I use T and P, okay. So then the P means that the difference of P on the right and on the left, so it has a difference of value of P. Okay, same with the T on the right and on the left, it has a difference of T. Okay, so by using this kind of force of polygon, okay, they derive for additional equation, okay, by differentiate between the force that acting downward with the force that acting upward. It does not include the delta P. Okay. So this is what has been improvised by Bishop, but it's very tedious. Why? Because we need to identify uh, the factor safety on the left and also the factor safety on the right. Okay. So then, for example, this is the factor safety on the left. Okay. So in this another equation, okay, so the equation has been improved, okay, where we need to identify what is the factor safety on the right. Okay. So because the MA is derived, this is the equation of MA, where it has the F factor safety value. Okay, so this MA is a part of this whole equation to obtain the factor safety on the left. Okay. So what should we do then? We need to assume the factor safety on the right. Okay. Then do the calculation. Okay. If the factor safety on the right is not equal to factor safety on the left, okay, which is the output. So we need to do a repeat until at least three times or three attempts. Okay. It's very tedious compared to the Philenis. Okay, but it can he can say that it's more comprehensive. Okay. It is more comprehensive compared to the Philenis. Okay, because Bishop consider the side force, which is the shear and also the normal force acting on each side of the slice. Okay. Okay, so this is a sum of approach that can we determine the MA. Okay. However, okay, we can do it manually, okay, without using this kind of we call as this kind of graph. Okay. We may discuss later on when we look on the example. Okay. Okay. So, okay, due to repetitive nature of the calculation and the need to select the most critical surface, FLA surface, the method of slices in particularly suitable for solution by computer. Okay. So at the end, this approach is suitable, okay, to be carried out by using a software. Okay, so more complex geometry and source strata can be introduced. There are other methods of slices issued in the following table. Okay, this method use different assumption on inter-slice force. Okay, so this is some of the what we call it of the approach. Okay, we have here. Okay, this is ordinary methods of slice, the one that we have discussed previously. Then we have a Bishop modified. Okay. Then we have a Jumbo simplified methods. Then we have a Morgenstern and Price, and then we have a Spencer methods. Okay, so they are they have evolved. Okay, for every decade. Okay, so a force equilibrium does not satisfy the horizontal and vertical force equilibrium. Okay, because they assume zero. Satisfied vertical force but not horizontal force equilibrium. Okay, so Jumbo has satisfied all. Okay, Morgenstern and Price also, and also the Spencer. Okay. So moment equilibrium, yes, yes, no, yes, yes. Okay. Shape of slip surface, okay, for ordinary is suitable for circular, but when it comes to non-circular, so it can it's not suitable to be used. Okay, then it's been improvised until any shape can be used to determine to carry out for the analysis. Okay. Okay. So that's all for this presentation on the slide. Okay. Okay. I will use Dr. Noligofa example, okay, because I guess I could not explain in detail using the Dr. Kamarudin example. So most probably we may discuss next week. Okay. So okay, this is method of slice. So you can read it again. Okay, the explanation from Dr. Noligopa example, and Dr. Noligopa introduction here. Okay. So this derivation. Okay, so we look on the simple one first. Okay. I guess I can explain on this one because I have another commitment after this. Okay. So we end a little bit early today. Okay, we look on one example only. Okay, so calculate the fact safety for a slope with a given failure plane. Okay, sorry. Okay, you may read on Dr. Noligofa introduction part, okay, on the method of slices here. Okay, so I guess most of my explanation are based on Dr. Noligofa introduction part. Okay, so this is for simple or ordinary methods. Okay, without introducing any pore water pressure or seepage in this example. Okay, calculate factor safety for a slope with a given failure plane in terms of effective strength concept. Okay, so the slope angle is 45, height is 15.24. Okay. The shear strength parameter of the soil layer, which is soil number A, is C 17.1, phi 18, gamma 17.6, while for the B layer, C is equal to 0, phi is equal to T4, gamma is equal to 19.2. Okay, so what is the factor safety value? Okay, so as can be seen in this example, okay, so for soil layer or slice number 1, it only cover one type of soil of A, while the soil number 2, number 3, and number 4, it only cover one type of soil of B at the base. Okay, so the factor safety can be calculated using equation 5.29. Okay. So actually, to determine the factor safety for this example, or using the method of slices, it is better to plot on a grid paper. Okay. Why? Because we want to determine what is the width and also the height, okay, of the soil in order to obtain the W. Okay. So the W is the width and average width. Okay. It is not a total width because we just use the B, which is the width, times with the center line. So the center line is H. Okay. So the length of circular arch A is 9, okay, based on the scale graph. Okay. Each component of the formula for calculating FS for is tabulated in table P5.11. Okay. So all the value has been put in this table. Okay. For example, slice number 1, okay, soil at the base A, okay, that is the type of the soil. And then we have the B for the slice number 2, 3, and 4. Okay. So then it is recommended to put in the scale graph, okay, but in this example, it doesn't show how it has been put on the scale graph. Okay. So then we just look on the example only where W is equal to 297. Okay, and the last one is 600. And the fee is equal to 18. Okay, 34 for the rest. And C is equal to 17.1 and 0 for the rest. So the length is equal to 9. Okay. So why on the can I have a break for one? Okay.
Okay.
Okay, Prof.
Hey, someone to go to toilet. Okay, wait. Okay, sorry. Okay. Okay, for the C is equal to 17.9, it's 17.1, okay. Sorry, actually to obtain the L, okay, we may use the equation, okay, where we need to determine the alpha, okay, but in this case it's not been discussed, okay, on how to determine the L, okay. So I guess for the next example, okay, for the next week, I will discuss on how to determine the L, okay. So why the value is not included here? Because at the end, although we provide the value of L here, so when it multiply with 0, so it becomes 0 because C needs to times with the L. However, for this case, the C is equal to 0 for the layer of B. So in that case, it's not important to introduce the L here. Okay. So then W cos alpha tangent phi. Okay. So alpha is not being discussed here. Okay. So there is the lack of this example. Okay, because alpha we need to determine by using the what we call as protector. Okay. So we just look on this example, okay, and then means that if we want to solve the problem related to the method of slices, so we need to put in a table. Okay, so then W cos alpha times tangent phi, okay, for the slice number 1 until slice number 4, the total is 2470. Okay, this is for the resisting moment, but this is for the driving moment. W sin alpha, then we obtain 1340. Why it has a negative value? Because the alpha, okay, if it is what we call as anti-clockwise, okay, oh sorry, if okay, this is the what we call as this is the point of origin, okay. So the alpha, okay, to on the right side, okay, become positive, but the alpha on the left side it become negative. Okay. So for this case, for the 4, slice number 4, so the value is become negative because the alpha is at the left side from the origin. Okay. So Dr. Nolly does not discuss on the alpha for this example. So later on, the value for the factor safety is equal to 196. Okay. I guess I need to stop. Okay, this is the alpha on how to determine the alpha. Okay, I will discuss on the next week. Okay. For the full discussion on the method of slices based on Fillenius and also based on Bishop. Okay. Okay. Sorry, I need to end a little bit early. Okay, because I have another meeting at 4. Okay. So I need to do some preparation before I have a meeting at 4. Okay. So we meet next week, same time. Okay? And then we may discuss on the method of slices based on Fillenius and also Bishop. Okay.
Okay, okay, Prof.
Okay. I will upload the recorded version, okay, in the e-learning. At the same time, I also have upload the take-home test, test number 1, take-home test, and also an assignment, okay, in the e-learning, okay. And then you need to submit by during the semester break. Okay? So please look at the e-learning. I have provided the
Okay.
huh?
Mid-sem.
Okay, Prof.
Both
of them, test and assignment at break.
Yes, in the e-learning. It is a take-home test. Okay. It is an individual assignment and test. Okay. Please look at the e-learning. Okay.